Dan and Sean, thanks so much for being with us here at Design News.
Yeah, thank you, Daphne.
Yeah.
It's good to be here.
Yeah, thanks for having us.
No, my pleasure. So, as engineers, wanted to ask you about your artwork and what inspired you to create artwork and gives you the daily inspiration.
Yeah, yeah. So, well, I think pretty much everyone would agree that the natural world is incredibly beautiful, right? And as engineers, we have to work within and through the natural world to make, tools and processes and algorithms that do something useful. So I think that beauty and the elegance gets kind of baked into the solutions that we come up with. It's just not always as apparent, I think, maybe from the outside. But, um, I think quite often the correct answer to a problem is also a beautiful one. And I think it's our goal to kind of bridge that gap, to show the beauty in science and kind of how that relates to the natural world. And yeah, so I think that's the natural world is the inspiration for a lot of what we're trying to do and to inspire in people to get them excited about science and math.
Can you describe your art? And I was told it was algorithmic art or STEM influenced art. So, can you explain that a little bit to us?
Yeah, yeah, I can take that one. So, I guess maybe in this age or this time, it's important to maybe say it's not AI generated, right? We're making algorithmic art in the most traditional sense of the word algorithm, in that there's a simple set of rules. Often those rules reference each other or the environment in which they operate. Um, and then they can interact with each other and generally lead to some complexity or some emergent detail. Um, and that's kind of like how that's basically what's happening in all of our art. And one example might be some of the code that I'm working on now. I like to think of it as like a metaphor for what's happening with um, crystallization. So, but instead of atoms, the complex physical world of atoms linking together and interacting with the environment, it's just a bunch of lines that have simple rule sets assigned to each line. And then you essentially seed a plane with those lines, and then they grow in kind of a crystalline pattern. But you can put in lines that have essentially a bunch of different angles, like you would find in a pile of blocks. And then what you get out is what looks like a block pile. Or you can put in, different angles that nature uses for branching that you see often with either vessels or trees or different plants, and you get out vasculature or you get out something that looks like a tree. Um, so that's kind of one of the examples in a nutshell that kind of emulates what we're trying to do. And I can provide a link to an example too.
Thank you. Thank you. It almost sounds like if you were trying to solve an engineering problem, envisioning it that way or looking to nature for solutions could maybe inspire a solution or and then I guess inspire art too.
Yeah.
Yeah,
And
and
we feel like they go back and forth hand in hand.
yeah, quite often, you set out to do something or to try to create something, and it doesn't work, but there's usually something there that you can develop into something that does do something beautiful or interesting that you hadn't developed and there or you hadn't intended. And there is kind of that science and engineering kind of workflow where you're making hypotheses about what's happening and refining it to try and get better results.
It's exciting.
Thanks.
So what brought you to MathWorks MATLAB for creating art? Is it something that you were already using in engineering?
Yeah. So we actually, I think both of us used MATLAB in grad school and professionally. And so a lot of my colleagues were working with toolboxes or algorithms that were developed in MATLAB. And I had started a few side projects to try to get better at math and science and just the programming, so that I would be better at my job. And eventually, through time, those started to produce some really interesting outputs. And our family kind of encouraged us and our friends to try and develop it more and get other people excited about science and math. So it kind of happened organically, we so.
Um, and so it kind of led to solving engineering problems, but then maybe opened up an avenue for considering art, or at least being the basis for some artistic expression.
I mean, I feel like they go hand in hand, and I feel the same way in that I started doing some work to practice and try and figure out different problems, and that work has actually also helped me become a better engineer. So, goes both ways.
That's very cool how engineering can inform art, but art could also inform engineering.
Yeah.
So MATLAB helps engineers perform calculations, build complex models, simulate and test designs, and more. So how does it relate to art and help you with art?
Yeah. So, I like that question. I think maybe it would be better if I like answer the first part and then kind of take a step back for the overall a bigger picture. So like MATLAB is our constraint system when we create art. Um, and maybe that makes more sense in like the context of um, art in general. Like if you take a step back and you think about what people do in art, you generally have people that, or you generally assign or you have a constraint system, right? A sculptor uses like a hammer and chisel and some marble or something to express or provide a message, right? There's a process and a goal there. And similar to that, we're using MATLAB and the analysis and simulation and modeling and visualization tools to create artwork and to create all the stuff we generate. We're not really using, Photoshop or After Effects. We're just, you know, outputting some algorithm, and it's like direct output is the images you often see on our website.
Very cool. So what did you learn about art or engineering while exploring MATLAB in this way?
Yeah. So a lot of things. I think actually we've developed, I think, two new ways or two new fractals, or if not, two new ways to generate fractals. And we're gonna try to publish that as soon as we can. because we'd like to share it with other people too. But also I've been getting into a lot of the color science because I do like trying to figure out how to do everything I need to do within MATLAB, just because, you know, it's kind of fun to try to figure out how those equalization and balancing, image like balancing and manipulation algorithms work. And I like trying to write my own. But there's also a very, I think, a human component to it where, you know, when you create a piece of art, you have an idea about, you know, what message it's going to have or things it's going to evoke. And then when you show it to someone, they quite often have a different interpretation than you, and totally valid. And just, I don't know, it's great to just talk to people about it and see the diversity of perspectives out there. It's definitely one of my favorite things about doing this, talking to people about it. So.
That's great. So how do you think your work would inspire other engineers?
So I think there's maybe two parts to that. The first part, like if we're just talking directly about the artwork that we create, I hope that people think about, you know, how is this made or what are they doing, and then poke at, you know, what are the underlying principles that we're using to create some crazy picture. And then with that, you know, I hope that leads to some inspiration of how can I maybe make my own thing? How can I make some, you know, whatever creative expression? It doesn't have to be artwork. It could be, you know, something in engineering too, especially for, you know, engineers. There's a lot of stuff out there. And then the part two is that, and I think we're kind of getting there in this conversation, is that art and engineering are kind of like two sides of the same coin. They're not exclusive to each other, right? And I think they can help they can help and complement each other. Especially if you think of a lot of engineers who create, you know, something that needs to be mass manufactured. Some part has to be very quickly made, very cost effectively made. And that takes some creative genius often to come up with some design that fulfills all those cost effective needs. Right. So I feel like that's some industrial artwork. And then on the other scale of, or on the other side of that for engineering, there's, you know, a one-off unique challenge, kind of like a telescope, like a James Webb Space Telescope that's going up into space, where you have a very constrained set of objectives, like cost. Cost is, you know, you have to factor in cost, but it's less of a concern, right? You can use exquisite materials, new processes, new things to try and meet the goal. So I feel like even James Webb Space Telescope you could consider as art, especially, you know, all the people who created it, say, are in some way artists. So yeah.
Yeah, that's a great point. It is, you know, accomplishing, you know, meeting requirements, and whether it's user or manufacturing, and coming up with something useful and beautiful is quite an accomplishment. So yeah.
Yeah.
Any final thoughts about art or engineering that you'd like to share with our audience?
I think just yeah, just get interested in something and try and explore it, because quite often the closer you look at something, the the more beautiful it becomes, the more interesting things you find. So I think that's what I would say.
I like that, Dan.
Yeah, great point to end on. Thank you. Thank you both. I appreciate your time.
Thank you.
You too, Daphne. Have a good day.
Yeah,
Thanks.
nice meeting.
Nice to meet you. Thank you so much.